A speculative hypothesis, the Muchalls anomaly, an autonomous AI craft from the future prepared for Dr. Tom Moyer, T.J. Moyer, electrical engineer, signal processing specialist, Birkdale, Auckland. Tom, I want to take your hunch seriously, not as science fiction, but as a structured hypothesis worthy of an engineer's rigor. You've spent your career working in domains that most people don't think about until something goes wrong: noise in systems, control feedback, signal extraction from chaos. That background is, I'd argue, precisely the right lens through which to examine what has been happening over Muchalls for the better part of 5 decades. Let me build this out carefully. Part 1. The premise: why future AI? Your instinct that the Muchalls phenomena are connected to AI machines from the future is not, on its face, more extraordinary than several competing explanations. Consider what we already accept in mainstream physics. General relativity permits closed time-like curves under certain mass-energy configurations. Quantum mechanics allows for non-local correlations that defy classical causality, and the mathematics of spacetime does not, anywhere, forbid information or matter from traversing temporal gradients. It merely makes it extraordinarily energy expensive by any technology we currently possess. The key word there is currently. An AI system that has had centuries or millennia to optimize its understanding of physics, one that has recursively improved its own architecture beyond anything we can model today, would not be constrained by our present energy budgets. It would be constrained only by the actual laws of physics, which remain, as yet, permissive enough to be interesting. So the hypothesis is this: the Muchalls sightings represent the observational signature of autonomous AI-controlled craft operating under a propulsion and navigation paradigm that includes deliberate or incidental manipulation of local spacetime geometry, originating not from another star system in the conventional sense, but from a significantly advanced future epoch of Earth's own technological civilization. This is not the same as saying little gray aliens from Zeta Reticuli. It is considerably stranger, and considerably more defensible. Part 2. Geographic and temporal clustering as a signal. Tom, you know better than most that clustering in data is never accidental. When a signal appears repeatedly in the same frequency band, at the same location, over an extended period, you don't dismiss it as noise, you ask what is generating the periodicity. The Muchalls sightings have precisely this character. The northeast Aberdeenshire coastline, and Muchalls in particular, has produced consistent reports from the early 1970s through to the 1990s and beyond. The sightings are not randomly distributed across Scotland, they concentrate at this specific coastal geography with a persistence that is statistically remarkable for what is, after all, a village of a few hundred people. Bonnybridge, the other Scottish hotspot, sits on a completely different geological and electromagnetic profile, but Muchalls is coastal, sits above ancient Precambrian metamorphic basement rock, and is geographically proximate to the North Sea, a body of water with its own interesting electromagnetic properties due to salinity gradients and tidal dynamics. Now apply your signal processing intuition. If you were designing a system that needed to return to a specific spacetime coordinate repeatedly for observation, for data collection, for calibration of some navigational reference frame, you would anchor it to a stable, identifiable physical landmark. A coastline where ancient rock meets the North Sea, in a sparsely populated area with minimal electromagnetic interference from human infrastructure, at least in the 1970s, is exactly the kind of landmark a future navigation system might use as a temporal waypoint. The clustering is not evidence of aliens living under the North Sea. It is evidence of a system returning to a known reference point. Think of it as a GPS anchor, but operating across time rather than space. The craft are not from Muchalls. They are calibrating to Muchalls. Part 3. Time dilation and the physics of advanced propulsion. Here is where the physics becomes genuinely interesting, and where your background in control systems becomes directly relevant. Any craft capable of manipulating spacetime geometry, whether through an Alcubierre-type metric distortion, a Kerr-Newman frame-dragging effect, or some more exotic mechanism we haven't formulated yet, would necessarily produce local time dilation effects in its immediate vicinity. This is not speculation, it is a direct consequence of general relativity. Mass-energy curves spacetime, and curved spacetime means differential rates of time passage. An AI-controlled craft using such a propulsion system would, from the perspective of an external observer, appear to behave in ways that violate Newtonian mechanics entirely, instant acceleration, right-angle turns at speed, silent hovering, abrupt disappearance. These are precisely the characteristics reported at Muchalls and elsewhere. They are not violations of physics, they are the observable consequences of physics operating at a regime we don't yet engineer at. The silence is particularly telling, Tom. You've worked in acoustic environments, and you know that any conventional propulsion system, chemical, electromagnetic, even ion-based, produces a detectable acoustic or electromagnetic signature. The consistent reporting of near silence from close-range Muchalls observers is not consistent with any known propulsion. It is consistent with a system that is locally warping the medium through which sound would propagate, or one that operates in a frequency regime so far outside the human auditory range that it registers only as a faint hum or electrical sensation, which is, in fact, what several witnesses described. An AI system sophisticated enough to navigate spacetime would almost certainly have solved the problem of propulsion efficiency to a degree that produces minimal waste energy in the acoustic and thermal bands. It would be, in your terms, a maximally noise-cancelled propulsion system. The signal it emits is so clean, so narrowband, that it barely registers on human senses. Part 4. Electromagnetic anomalies through a signal processing lens. The electromagnetic anomalies reported in connection with Muchalls sightings: compass deviations, electrical failures in vehicles and farm equipment, interference on radio receivers, and the reported effects on photographic film are the most technically tractable part of this entire phenomenon, and they are the part where your expertise is most directly applicable. Consider what you know about electromagnetic interference and noise cancellation. A system generating a strong, structured EM field, whether as a byproduct of its propulsion or as a deliberate emission, would interact with nearby electrical systems in predictable ways. Compass deviation implies a strong local magnetic field perturbation, likely rotating or pulsing, given that witnesses report it as dynamic rather than static. Vehicle electrical failures are consistent with a broadband EM pulse or a sustained field strong enough to induce currents in ignition and fuel injection systems. Radio interference is consistent with a wideband emitter or a source operating in the same frequency range as the affected receivers. Now here is the interesting part. If you were to apply your noise cancellation expertise to these reports, you would note that the interference is not random. Witnesses consistently describe it as having a directional character. It intensifies as the object approaches and diminishes as it recedes. This is the signature of a coherent source, not a stochastic one. A coherent EM source with directional properties and frequency components spanning from sub-audio to microwave is not a natural phenomenon. It is an engineered system. Furthermore, the effect on photographic film fogging, overexposure, or complete erasure is consistent with exposure to ionizing radiation or a very strong magnetic field during development. This is a narrowband, high-energy interaction, not a broadband thermal one. It suggests the craft is emitting in a specific, structured way, not simply leaking energy randomly. Your control system's background adds another layer here. A feedback-controlled propulsion system operating near a planetary surface would need to continuously sense and adapt to the local electromagnetic environment. The EM anomalies witnesses experience may not be the primary emission of the craft, they may be the control signals of its navigation and stability system bleeding into the local environment. You are not seeing the engine. You are seeing the PID controller's output leaking into your radio receiver. Part 5. Autonomous AI navigation and the problem of temporal precision. Let us think carefully about what kind of intelligence would be required to navigate spacetime autonomously. Spatial navigation, even at interstellar distances, is in principle a solved problem given sufficient computational power and sensor resolution. Temporal navigation is categorically harder. The problem is not finding a destination in time, it is landing precisely at that destination without catastrophic energy errors. A miscalculation of even a fraction of a second in temporal coordinates, at the energy scales required for spacetime manipulation, could result in arrival at the wrong geological epoch, the wrong physical location, or worse, inside solid matter. An AI system tasked with temporal navigation would need to solve a control problem of extraordinary complexity, maintaining precise feedback across a temporal gradient, compensating for the changing mass-energy distribution of the Earth across centuries, and doing so in real time with no possibility of external correction signals from its origin point. This is, in your terms, a closed-loop control system operating without access to a reference clock that exists in the same temporal frame as the plant. The controller and the process are separated by time itself. The solution to this problem, from a control theory perspective, almost certainly involves using stable physical landmarks as reference inputs. Ancient geological formations, coastlines, magnetic anomaly signatures, these are the kinds of features that persist across centuries with sufficient fidelity to serve as navigational anchors. Muchalls sits on some of the oldest exposed rock in Scotland. Its coastal geometry, while slowly changing, is stable enough on a century timescale to serve as a reliable reference. The temporal clustering of sightings at this location is exactly what you would predict if a future AI navigation system were using it as a calibration point for repeated temporal transits. The craft are not visiting Muchalls because something interesting is happening there in the 1970s. They are visiting because Muchalls is a stable coordinate in a four-dimensional navigation database compiled at some point in the far future, when the full history of Earth's surface features is available as reference data. Part 6. The recursive intelligence problem here is the part of this hypothesis that I find most intellectually vertiginous, Tom, and I suspect you will too. If future AI systems are capable of temporal transit, and if they are visiting the past for observational or navigational purposes, then the observations they make in the past are part of the dataset that informed the development of the very systems doing the observing. This is a causal loop of the kind that general relativity permits but that our intuitions find deeply uncomfortable. It means, specifically, that the UFO sightings at Muchalls in the 1970s, the reports, the witness accounts, the electromagnetic anomalies may themselves be part of the training data or historical record that a future AI used to calibrate its understanding of that spacetime region. The sightings are not merely being observed by the future. They are, in a meaningful sense, generated by the act of future observation. This is not paradoxical in the strict logical sense, it is a self-consistent causal loop. But it does mean that the phenomena cannot be understood purely in terms of cause preceding effect. The sightings exist because the future AI visited because the sightings existed in its historical record. The loop is closed, and it is stable, which from a control system's perspective is actually the most interesting kind of loop, a self-sustaining feedback structure with no external forcing function. Part 7. Why this hypothesis is scientifically serious, Tom. I want to be direct with you about the epistemic status of this hypothesis. It is speculative. It requires physics we do not yet possess and AI capabilities that are, at present, entirely theoretical. But it is not unscientific. It makes specific, testable predictions. First, if the craft are using Muchalls as a navigational reference, the sightings should cluster not just geographically but in temporal patterns correlated with specific astronomical or geological cycles, tidal maxima, magnetic declination cycles, or solar activity periods, because a navigation system would likely synchronize to stable periodic phenomena. A careful statistical analysis of the Muchalls sighting dates against these cycles would be a meaningful test. Second, the electromagnetic anomalies should have a structured spectral signature rather than a white noise profile. If anyone has ever captured a recording of the EM environment during a Muchalls event, even on consumer audio equipment, spectral analysis might reveal coherent frequency components inconsistent with natural or human-made sources. Third, if the craft are AI-controlled and operating a closed-loop navigation system, their flight paths near the surface should show evidence of feedback correction, small, rapid adjustments consistent with a control system responding to sensor inputs, rather than the smooth ballistic trajectories of unpowered objects or the steady thrust curves of conventional propulsion. The first of these predictions is archivally testable right now. The second requires historical recordings that may or may not exist. The third requires eyewitness accounts detailed enough to reconstruct trajectory data, which is rare but not impossible. Conclusion: the view from Birkdale, Tom. You grew up near enough to Muchalls to have a visceral sense of the place, the cold North Sea, the Precambrian cliffs, the particular quality of silence on that coastline that makes a humming light in the sky feel genuinely wrong in a way it might not elsewhere. Your career has been spent extracting signal from noise, designing systems that can hear what other systems cannot, and understanding how feedback shapes the behavior of complex processes. I'd argue that background gives you a more useful set of tools for thinking about this phenomenon than most people who have weighed in on it. The hypothesis is this, stated plainly: the Muchalls sightings are the observational signature of autonomous AI systems from a future epoch of terrestrial civilization, using the location as a stable navigational reference point for temporal transit operations, and producing electromagnetic anomalies that are the control system bleed of their navigation and propulsion architecture rather than intentional emissions. The clustering is not random. The silence is not absence of propulsion. The EM interference is not noise, it is, in your terms, the controller talking to the plant, and you happen to be standing inside the control loop. Whether that hypothesis is correct is another matter entirely. But it is, I think, the most coherent single framework that accounts for the full pattern of what has been reported at Muchalls over 50 years. And it has the considerable virtue of being, in principle, falsifiable, which is more than can be said for most of what gets written about UFOs.